path-breaking design for artificial general intelligence. We will examine the following in this presentation. An explanation of the problems with current AGI designs. Identification of an alternative design strategy. Explanation of why the new design is better. The problem with current AGI. They are fundamentally based on objects. However, objects are not foundational. This can be seen in the context of problems and solutions. All objects can be abstracted as solutions to some problem. Each object solves some problem, but does not know that fact. Any collection of objects for intelligent functioning requires external intelligence to function. This means, using a set of objects to create AGI is like solving the chicken and egg problem. This is a direct consequence of the fact that objects are unaware of the problems they solve. That awareness and the ability to exploit the functionality of the objects must reside outside. It is true that objects can be wielded to show intelligent behavior. However, objects cannot do the wielding to create intelligence. What is missing? The obvious starting point is that problems must precede solutions. It is not possible to make sense of any object or solution without the awareness of the problem being solved. Therefore, problems must be more foundational than solutions or objects. However, problems are subjective. This implies that problems must be expressed using terms of subjective experiences. Experiences in turn implies awareness and consciousness. Furthermore, a computational framework for this is needed. Philosophy of subjectivism. Subjectivism can be divided into three: simple subjectivism, emotivism, and reflective emotivism. The last, emotion-based, but with due reflection before forming subjective representation, seems most promising. This, together with Jerry Fodor's representational theory of mind, RTM, and the computational theory of mind, CTM, seem like good starting points. Therefore, representation of subjective elements, and performing computations on these is essential. Furthermore, these computations must seamlessly interface with algorithms for processing sensory inputs and manipulating objects. Proposed solution. A representational system of subjective elements that can be refined and enhanced through learning. A broader concept of perception is used in the representation. Problems are defined as the gaps or distances to desirable perceptual states. Objects and their use cases help bridge the gaps, thereby solving specific problems. Perceptions are represented using Osgood's EPA space of affect control theory, ACT. This allows the computation of the emotional impact of a problem, and therefore, the value of the solution. Behavior control. While ACT allows the computation for selecting a behavior, perceptual control theory, PCT, of William T. Powers helps control the execution of the selected behavior. Here is an example problem. You wish to silently attract the attention of your friend in class. The problem is defined by the gaps in your desire to be silent and draw her attention. You could roll a piece of paper into a ball, and throw it at her. The subjective characterization of the problem with ACT, and the feedback control of PCT needed to hit only her are needed. This kind of freedom to use objects subjectively is essential in AGI. Subjective control. Look at the nondescript cover on the right. However, familiarity with stereograms will change your perceptions. This helps you to redefine the problem. The unconventional way of viewing produces an amazing 3D image. This kind of subjective control of objects is the essence of intelligence. However, this requires a computational model of many elements normally considered as non-computable. Computable intelligence. In this book, I go into details about representations and computations to achieve consciousness and other various cognitive elements. The sequence of steps needed to acquire intelligence through the process of learning and training is discussed. Various types of cognitive computations are explored. It is argued that this approach provides the most promising path to AGI. However, this is meant only as a starting point to initiate productive discussions on this fascinating new approach. The author is aware of the need for the contributions of others, and is available to hear comments, criticisms, and suggestions at